So let's see if that's full. All right, so to finish this one off, put all your answers together. Okay, so power of 3, you only get one possible answer. Power of 2, you get a plus minus, but again, don't correct that, please, for me. And then we get the 4. And yes, it's an order 2, but we only state it once. So then my final answer would be therefore x equals 4 and negative 2, and that's it. Okay? So next page, we're going to do that again. Now, before we start, so going from here, that third root, we haven't done a lot of third roots. We haven't done a lot of third roots since a while, right? Since grade 11, we did like third roots and such. Here, we're going to pause for a minute, and I've got a little box of memories here. Okay, and I want to remember how to simplify a radical. Okay, I always want this to be exact. Okay, no decimals. Okay, whenever I had radicals, after we taught you, right, the radicals in grade 11, how to do this, we asked you to simplify. So even though root 24 is not a perfect root, we asked you to simplify, not to go to decimals. So exact, no decimals. What did I mean by that? Is that you were looking for your perfect squares. So this is a square root of 24. Doesn't work out exactly. So I asked you to look for perfect squares. Perfect squares were, what are perfect squares? 1 times 1, not useful. 2 times 2, so 4. 3 times 3, 9. 4 times 4, 16, right? Etc. Those are perfect squares. So perfect squares, 4, 9, 16, etc. What goes into the 24? That would be a 4 and a 6. I know it's 12 times 2. I know it's 8 times 3. Those are not perfect squares. I'm looking for a perfect square because it's a square root, so the 4. So square root of 4 is 2, exactly 2, and you leave your remainder inside there, root 6. Okay, so that's what we wanted. We always left it exact with no decimals. That's simplified without going to a decimal. All right, rings a bell. Okay, so that rings a bell. We never did a lot of simplifying with third roots, but we're going to practice that in a minute. They are assuming that you can simplify a third root because you know how to simplify a square root. The same process holds true. Okay, so here. Third root of 27. What's the third root of 27? 3. And we're looking for perfect cubes. So perfect cube would be 3 times 3, 2 times 2 times 2 would be 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64, etc. Right? So we're looking for a perfect cube because it's a third root. So it's exactly that. You can do that on your calculator. On your calculator, there is the button with the little X there above, and you would go shift third root of 27, and you'll get that. You get the 3 back. Okay, so you can do that on your calculator. We shouldn't need a calculator, though, right? That's only for, like, in desperation. I can't remember what 3 times 3 times 3 is, but you shouldn't really need it too much. You'll know enough of the numbers, right? Here. What's the third root of 24? So if you did that on your calculator, you would get an awful decimal because third root of 24, we know 2 times 2 times 2 is 8, 3 times 3 is 27. There's no 24, right? That's not a perfect cube. I want you to simplify it, not go to decimal, the same way as we did 24. So you're looking for a perfect cube. Perfect cube. So that would be 8, 27, 64 is too big. 27, it's only 8. Does 8 divide into 24? Yes, it does. Right, we're going to go like this. I'll try this one. So we're going to go third root, right? And that would be 8. So perfect cube, how do I know it's cube? 3, okay, is 8 times 3. Now what is the third root of 8? 2, right? 2 times 2 times 2. We just said that. It's a perfect cube, just like we did this one. So that would be the perfect 2 comes out and leave the leftover inside. Make sure I can read your writing. It's not about neatness, it's about accuracy. So make sure that's a third root, not 23, right? So it has to not look, some people actually make it so big, it's like this, and it's like, it can't be that big. So it should be slightly smaller like that. And some people leave a bit of a space like that, that's fine, right? So it doesn't look like third power, but it should be slightly in that little tick mark here. It should be kind of in there, okay? So just make sure it doesn't look like times 23. All right. All right, so there we go. And then over here, try it again. Okay, and that's perfect. That's beautiful. It's simplified, but no decimal. Is there a perfect cube for 81? 64. 4 times 4 times 4. No, 5 times 5 times 5 is 125. Too big. So it's somewhere in between these guys, right? So it's somewhere in between, third. So then we're going to look. Does 8 go in? No. 27? Yes. So we're going to go like this. I'll change colors. So we're going to go like this. We're going to go third root. And 27 does go in nicely, times 3. Right? What's the third root of 27? We just did that above here. It's exactly 3. And leave the leftover inside. Third root 3. All right, making sense? Okay, again, third root of negative 250. So as soon as I see 250, I'm looking for a perfect cube, 64. After 64 would be 5 times 5 times 5, so 125. That sounds good to me. And we're going to go with, okay, negative 125. You're allowed to use a negative for a third root. Negative 5 times negative 5 times negative 5 times 2. So third root would be, take out the negative 5. And here, third root of 2. Do I want you to take out the negative? Yes, please. Whenever possible, we take out the negative rather than leave it inside. So if it is possible, yes, I do want you to take it out. Okay, 2 more times. This one. 4th root of 64. Okay, so 4. So we're looking for perfect 4. 2 times 2 is 4, 8, 16, 16. 3 times 3, oh, times 3, 81. That's going to be too big, so it has to be the 2. Does that work? That would be 16. 16 goes into 64. Yep, it does. You can't force it. If it's not, if you can't simplify, you can't, but it does simplify. So then we're going to go 4th root of 16 is just 2 and leave the leftover inside. That makes sense? Right, so we're simplifying as much as we can. So this simplifies with that, this simplified with that. So whatever we can, we simplify and we leave the remainder inside. Okay, one more time. One more time. How do I do this one? Third for 64, looking for your perfect cubes. 8, 24. Oh, it is 64. So just write 4. That's it. No remainder. Okay, don't force a remainder if there isn't one. And if it's not something you can simplify, you just leave it as is. Yep. Yes.
If it's an even exponent or even square root, do you still want us to write the plus minus?
No. Okay. So then that is, if I give you, so the question was the even exponent, right? So if I say, what is the square root, what's the 4th root of 16? What's the answer to that? Just 2. Just 2. If there's no plus minus out here, you're not going to create a plus minus. The reason why you get the plus minus is this case. If I start you with x to the 4, then you're making the root. So that's when you do this, plus or minus 4th root of 16. So that's when you start from this, you're getting the plus minus. If the question is just what's the 4th root of 16, don't plus minus it. Yeah, and that's a good question because a lot of people, you're trying to fix what you think my mistake is. I didn't make a mistake. I just wanted the 4th root of 16, that's all. So if I said to you, what's the square root of 9, your answer is 3, exactly. So your grade 9 self would have been 3. Now you're like, plus minus? No, no, no. don't overthink it. Square root of 9 is just 3. So if I put the root there, I'm telling you which one I want. I just want the positive, right? If I wanted the negative, I would put negative. If I want plus minus, I'll put plus minus. So if I put the root there, just answer the question, right? And exactly, now that you learn that, you actually overthink it and you try to do more. If you're creating it, so here, if you've got the 4 and you're creating the root yourself, from that, that's when you put the plus minus. Does that make sense? Right? So if my question is just that, don't overthink it. Go back to your grade 9 self. Well, your grade 9 self can't do that one, but here. Right? So just take the question as is. So don't create it if I asked it for you. If you're going from an even power, then you have to do the plus minus. Okay? That's a good question because that does come up a lot. Is that too glowy? Sorry. Just letting you know. Okay? Does that make sense? So here, just answer the question I asked. Here you're creating it, so that's when we want plus minus. So you created that. Okay, good. Okay, good, good, good. Okay, I'm going to pause this